the use Java thread. Java thread, even though you do not explicitly you do not use the Java thread, whenever you run the program, the Java application automatically Java use thread instead of creating the process. Okay, Java virtual machine itself is the one process. You can see the JVM or something like that when you check the process. Then whenever you run the Java application, it creates the thread within the Java virtual machine. So this is an example of the pthread. Then what's the benefit of using that? Responsiveness, which means if one of them is blocked, we can run another thread. However, if we are using just the process, if we stop, whatever the reason we stop at certain the instruction, there's no way to proceed. Okay, so it will be like the infinity loop was is something locked, so you cannot proceed. However, in case of thread, because we can create another thread to proceed the problem, so it's kind of the responsiveness. And also we can obviously share the resource, so it's a benefit. And as I mentioned, it can be used for the MP architecture, means multiple processor architecture. When we have the multiple process. By the way, there are two types of computing architecture in terms of the multiple processor. One is SMP, another one is MPP. Both of them are NP architecture. SMP means symmetric massive processor. For example, how many of you are using the dual core, a dual CPU? Anyone? So is it dual CPU? Suppose that. So you have the two CPU. Some of the laptop has the dual CPU, not dual core. Dual core we will talk about later. The dual CPU, two CPU. Okay. So do you realize that you are using the two CPU? Mostly not. Who is in charge of that? Operating system, no. Logically, it's considered one CPU. Okay, it's called the SMP machine. So SMP machine is logically we consider one CPU, but they are working together. Operating system is in charge of the symmetric massive process. MPP is I always forgot what this stands for. You can find. Okay, it's not it's something process. It's like the CPU and memory. CPU and memory. It's a shared the disk only. Or even sometimes shared nothing, only connected. It's a really pair number of nodes. Nowadays it's called cluster system. You heard about the cluster system. This is the MPP machine. So SMP is in one system, there are multiple CPU, but logically considered as one. So operating system know how to balance, how to use this one. User may not know. Okay, so this is like the multi-core, dual core, quad core, similar. Okay, that is SMP machine, and this is the MPP machine. So nowadays, using thread. If we create the one thread, we can do the parallel programming using thread. Sometimes it's not that simple for the parallel programming. You need to design the separate the job and even consider load balancing. Okay, but we are not going to spend a lot of time to talk about such a parallel programming. But thread is one of the ways. So how much fast? So we can compare the overhead to create the process versus to create thread. Okay, so somebody already benchmarked the fork versus thread. Okay, which one is faster? Don't have to pay attention to a lot the number, but roughly the 30 times the faster than creating process. So 30 times faster. It's pretty much good. And also, question. You can see the user sys where user sys. What does that mean? Anyone? This is a performance, the benchmarking performance test result. Then we can see the fork and P thread. It's a time actually. Okay, this is a time. This is the, for example, 60 and 7. And sometimes the 23, 2, and this one is 3.42 and the point, so much faster. Then at this time, this is a real, this is a user, this is a sys. What does that mean, each of them? Can you guess?
Real is the combination of user and system.
Slightly less than that. Why? The real is, so for example, when you test the program, so I implement very fast the algorithm. So how do you test? You need to check the how much fast. How do you check the how much fast?
Time complexity.
Using?
Time complexity.
Yeah, time complexity, that is the best way. But you need to show using the experiment, like the coding.
Yeah, like
Stopwatch. Many of the students check the speed efficiency with the stopwatch. That is a real time. It's a wall clock time. You can watch it. Click, then see how long. So 61.94 seconds. Can you believe that result? Why? In addition to your program, there are a lot of things going on in your computer. Networking and the daemon process, FTP, whatever, scheduling. So this number, this second, this time include, in addition to this one, there are more overhead. So we cannot believe only this. So we are going to measure only what? CPU time. Okay, so these are the CPU time. Then question, what is the difference between user and sys? Computer operating system, hint, dual mode.
So system is when it goes to the kernel.
This is a kernel CPU time. This is the user, the CPU time. So CPU anyway works for the user mode as well as the kernel mode. So this is the amount of CPU time for during the user mode. This is amount of CPU time kernel mode. You can see the which one is higher. This one, which means most of the operating system has the 2 or 3 times of the CPU kernel time than user time. So usually 1 to 3, 1 to 2, 3, 1 to 2, or 1 to 3, sometimes 1 to 4. So usually recommend 1 to 3. If your system has very high the CPU, the kernel time, which means your application may not get enough the CPU resource. Also, on the other hand, if your application use a lot of CPU, like the one-to-one, that means eventually CPU, your kernel cannot execute the system library, system code properly on time. So it is recommended 1 to 2 or 1 to 3 ratio of the user and system. How do I know this? There are existing command. Let me use this time. You can do the same thing using the virtual machine. So there's a command like the VM state. So you can see the CPU. It shows the instance, the statistic. Virtual machine means it's an instance. The system status process. How many running queue and the swap space, free memory space, and the page in and out. Later we will talk about this is how many I/O. Then this is a user time. 1% of the CPU is used for the user, 2% or 1% used for system time. And these are the idle. So 99, 98, this is because I'm not running the any specific program. And the wait, if there's any IO, wait, so it will be. So you can see the user and sys. So this is one of the very the popular command monitored by the administrator. So administrator would like to see whether it's well balanced or not. Okay. So this is a user time and sys time. And also, while you are running the program, I forgot the command. There's a command to measure user time and sys time whenever you run the application program. So it's not W time. Oh yes, the time. So while I'm running ls, what is the real time? What is the user time? What is the sys time? In this case, inside the instruction of ls command, there are not many kernel mode. Okay, because of that is the point 004 the second, and real time. This is should be higher, but each one has a little bit different information. So you can check the time manual page. It shows the information about that. Okay. So that's the performance of the fork and UCC. Then, as I mentioned, there are two threads. One is a user thread, and another one is a kernel thread. Who create the user thread? User. Okay. Who is the user? Your program. So in your program, you can create the thread. Have you ever did the thread programming in your programming class? That is a user thread. Okay. Then on the other hand, for example, the POSIX, the P thread, Windows, the 32 thread, or Java thread. Probably you use the Java a lot. Okay. On the other hand, the kernel thread will be created by your operating system kernel. You may not realize. Okay, but it used also kernel. So these are the example of such a kernel thread. Okay, and you probably heard you have seen this kind of the architecture, the multi-thread programming, the server architecture. Server keep receiving the request, the client request. That is your program. Then whenever request the thread, then it will create or locate the thread like this one. Okay, so we have seen the multi-programming and so on. So for the user thread and the kernel thread, so there are, because it is the dual mode. So user mode and kernel mode. User has thread and kernel has the thread. As we have seen, so for example, K thread, one of them or some of them will be used. So depending on how to allocate the number of the thread between the user mode and kernel mode, there is possible like the many user thread works for request to the one kernel thread, many to one, or one to one, many to many, like this. So this is the many user thread, but you have only one kernel thread. So at that time it will be bottleneck, obviously, and also you need to schedule among the multi-user thread. So because of that, sometimes this is called the also scheduler, like the processor. This one is a lightweight processor. It's kind of act as the CPU. Okay, process the user thread request. Okay. So for example, Solaris green thread and the GNU portable thread use because it's a simple, because we have only one kernel thread. However, so it's a bottleneck. To address that one, we allocate one user thread to the one kernel thread. So it's a dedicated the match. The Windows uses such a thing, so or the Linux, they one to one. The problem, a lot of the kernel thread you need. Okay, so to address that one, we are using in general the many-to-many. Similarly, we need to have something scheduler. This is called the lightweight processor. So we need to schedule such a thing. Okay. Most general part is a hybrid approach, like the many-to-many, or if we need it, we can allocate the dedicated one-to-one. The user and the kernel thread. Many of the Unix system actually uses commercial. As you can see, commercial Unix system use such a hybrid approach. Okay. Then I already explained the pthread, and these are the example of the pthread. If you already did the thread programming before, it is not difficult. For example, I'd like to create the thread for the sum of the number. Summation of the number 1 plus 2 plus 3 plus 10. Okay, to do that you need to create one class or one function or one something module. Okay, then assign that module to the thread. For example, here, so these are just the general programming, but we define the pthread. Then this is the learnable. Okay, module, function, learnable module, so it's just the summation of the number up to 1 through input number. So this will be used when the thread is created. So if you want to create the multiple, you can run this one multiple time. So it will be multi-thread programming, like I want to create based on the number of threads. So you can create join, then you can create the multiple threads. What about the Java? It's a window. Window is the same thing. So same, and we can create such a, where is the sum? Here. This is runnable. The module is a summation function. So summation will be called when the thread is created using the create thread, the system library, Windows API. So you can assign this one with the parameter value. It will be created. And what about the Java? Java, I believe that you already did. So Java is the same mechanism. We can create a summation class. Okay, sum and the summation. Then we will make the runnable class here. Then when you create instantiate the new thread, assign this summation. Then it can be start with the start method and join. Okay, like this one. If you want a multiple thread, you can do the multiple time using the loop. Okay. So there are several other examples used for the kernel. Used by the operating system is called the implicit threading. So you didn't create the thread, but whenever you execute the program, operating system automatically assign the thread for better performance, such as the thread pool or Grand Central Dispatch is used in the iOS also. So we will see the quick review. Such a thing. Thread pool is, so instead of creating, anyway, when you create the thread, you need to allocate the resource. You need a resource. It takes a time. So what if we create the kind of empty thread? We reserve the space first. There's no instruction inside yet. Then whenever it is requested, or if operating system believe we need a thread, the programming, then use such a existing thread. That existing thread is called the thread pool. So thread pool is the already created, managed by the operating system, that even though you may not realize it's a threaded programming, it will be used. Similar approach is a Grand Central Dispatch. So if you are using such a block, like what is the name of this one, whatever, and the symbol, and between the parentheses, this will be threaded part. Okay, so like the runnable part in the thread. So this will be executed by the thread implicitly. Even though you do not specify the thread programming, it will be using the operating system. There are several thread issues, so we will quickly review. When we fork, what is a fork? copy the parent process, clone, right? Then share the instruction, programming part. So why? Because we need to reserve the resource. We need to find the memory location. What if you fork inside the thread? Copy parent, copy only thread, right? That's the dilemma. So depending on the operating system. So I didn't test, but depending on the system library of the fork, so you can copy entire process, even the parent process. Or it can be based on the only thread specific. Process structure plus thread specific. So thread will be cloned. Okay? So that is, however, EXAC, not a problem. EXAC is just load, copy the instruction part only. So EXAC is not a big deal, but when you are using the thread, so in case you need to fork or create a new thread, you need to think about how, you need to check how the system library, your operating system and the programming is working for such a part, especially. So thread, when you are doing the thread programming, there are a lot of issues. One of them is synchronization issue, right? I expect one, but it's updated by another thread, so it will be weird, the output. So you need to always be careful to further such a communication. That's the signal handling. So we talk about the further basic communication of among the process. It's a signal. The interrupt is the signal. What if the thread specific signal? Who received that signal? Your process or thread specific? So for the communication purpose, you need to check. It's also various. You can communicate between the thread, but for example, RMI, the Java RMI, there is allocate the common the area, so you can communicate through the RMI, or some of the operating system need to communicate through the parent process. Then communicate to the thread. And also terminate the thread. So the parent process needs to terminate the thread. At that time, it can be asynchronous and the deferred cancellation. So asynchronous means even though your thread is running, but it will be forcibly terminated. Or sometimes you can just send a signal. If you are done, you need to terminate, because the thread also occupy the resource. Then at that time, it's a default cancellation. Means until it reaches the last instruction, it will be running, but later it will be terminated. So each thread library provides such a method to cancel or to terminate the thread. As I said, so because we are using number of the user thread, number of kernel thread, this should be scheduled. So because of that, it's called a lightweight processor. So because it's scheduled. Also, they need to communicate. Sometimes they can ask, I need more the kernel, or I can work for the other user thread, something like that. This is called upcall communication, in case many to many. Okay, so I'm going to skip the example of Windows. We have Windows and the Linux thread. I quickly discuss about the thread. Any questions? I think that because most of the programming class learn the thread programming, the Java and the C++, so you already use that. So those are the user specific, the thread, but the kernel also use the kernel thread. So while you are using the thread, you need to think about the issues of the thread. Okay, so let me start here. Then we are going to start the next 30 minutes. We will have the exercise lab for Unix programming. So next week you will present the project. Next week, the Daran will prepare the brief of your project, what you need to do. It doesn't show the solution, okay, but for those who are still confusing what you need to do, the Daran, after the second exercise lab or Unix programming, he will present about your project. Okay?
One
Yes.
question about the project. It's like individual project or?
Yes, individual project.
Okay.
Okay. Using the virtual machine. Okay, why don't you bring the compute engine? Even though he couldn't cover all the details of the exercise lab, it's your responsibility after the class to complete the rest of the remainder. You don't have to. What is the database name? I mean the show database.
All of you please log into
Which database are you using?
it's a connection.
Use the MySQL. Then why don't you run the show user. Use this one, this one.
Okay. Shell programming is nothing but a group of commands. You will be writing it in a single file and you will be executing it. Unlike C or C++, it's not a compiled one, it's a interpreter one. Interpreter is like it will go each line by line and it will execute the commands. These are the common shells available, like C shell, Bourne shell, or the K shell, or the Thomas C shell. Let's see what shell we are having in our connection. For that, just type echo if you type like echo $shell, it will show what's the current shell we are using. It's the bash shell. And to see what are the available shells you can use in this connection is give char you could see these are the available shells you can use in this connection, sh, bash, and C shell, and Thomas shell. And to declare a variable, first you need to have the format like you should first give the variable name. It's not type specific, it can be a integer, string, or the float, and then the assignment operator, and you should give the value. No need for any semicolon, or it will just read line by line. So once you are done, just give the enter. The value will be stored in the variable. And note that you should not give any space between these three, otherwise it will take it as a command and it will throw an error. We can see it in example. And to print the value, just type, already the echo command is like a printf statement, echo this dollar symbol is used to retrieve the value in the variable. If you just remove the dollar and just type echo variable name, it will just take it as it is, display the whatever you are just typing it here, it will just display it. And another thing you need to note is this is one way to print the statement, and if you like typing it under the double quotes, it will also give the exact same result. And what if you are typing it as a single quote? This will not give the exact one, because if you are using a single quotes, it will display whatever you are giving